Woohoo! It's a great day to learn some pre-calculus. I'm Miss Leg Battles, and I'm here today to review with you about law of sines and law of cosines. Often students know the law of sines and the law of cosines, but they just don't remember when to use them. So my goal today is to simplify that for you. First of all, we need to talk about what we've been doing up until now before we studied law of sines and law of cosines, and we were just solving right triangles. To solve right triangles, first of all, we use Pythagorean Theorem. We use Pythagorean Theorem to find the third side of a right triangle if we already know two side lengths. And then we also use the right triangle definitions of the trigonometric functions. I know you remember SOH CAH TOA, sine is opposite over hypotenuse, and so on. So we use those trig functions to find a missing side length if we were given one side length and one angle measure, or to find missing angles if we were given two side lengths. Now, again, remember, this was all for right triangles. Now we're going to learn how to use trigonometry to solve oblique triangles. So you may ask, what are oblique triangles? Oblique triangles, it's very simple. They're just triangles that are not right triangles. If they're any other kind of triangle, then they're oblique, and we can use, that's right, law of sines and law of cosines. So let's review what law of sines and law of cosines are. Our rules state that for the law of sines, that sine of an angle measure, let's call it A, over lowercase a. Now let's remember what this means. Lowercase a is a side length, and it is opposite from capital A, which is an angle measure. And that's equal to sine of B over B, the lowercase b, which is equal to sine of C over lowercase c. And the law of cosines, normally we see it written this way, that a squared is equal to b squared plus c squared minus 2bc times cosine of A. Now, notice that this A, this capital A, is the angle that is opposite from this lowercase a, which is a side length. So you really just have to know how they're all related. Now, sometimes you may see the whole formula written where it's solved for cosine A, because sometimes when we use law of cosines, we're finding that angle measure. The next question that we need to answer is, when do we use the law of sines and when do we use the law of cosines? Of course, we're using these for oblique triangles, but what information is given that causes us to need to use one or the other? Well, let me just simplify this. If you can use the law of sines, then use the law of sines. You'll see that it applies. Law of sines will apply when we have angle, angle, side, if we know two angles and a side that's not included. If we know angle, side, angle, that's two angles and the included side. So anytime we know two angles and a side, law of sines will apply. Well, it also applies in the ambiguous case, okay? The dreaded side-side angle, because we know that sometimes we write that as angle side-side. But also the law of sines will apply, but it is called the ambiguous case. Let's see if I can spell that. Ambiguous. Gosh, I hope that's right. It's the ambiguous case because it could have no solutions, it could have one solution, or it could have two solutions. Whereas in these other cases, it has the angle side and the angle side angle. There's just one possible solution for those. Now, when do we use law of cosines? Well, whenever law of sines doesn't work. That's when we're going to use law of cosines. Let me give you an example. Let's see. Let's say we were given a triangle that looks like this. Let's label the vertices A, B, and C. And we're given some lengths. Let's say this is 5 and this is 6. And we know an angle measure. Let's say this is 42 degrees. And we tried to use the law of sines. Law of sines would be sine of A over lowercase a equals sine of B over lowercase b equals sine of C over lowercase c. So we're going to go back and substitute in. When we do that, A is 42, so we know that value. We know sine of 42. But we don't know the A, the lowercase a. Because see, the lowercase a would be right over here. We don't know what that is. So that would be equal to sine of B, which we do not know, over lowercase b. Well, we know that one. Lowercase b is opposite from capital B, so that's a 6. And then sine of C, which we do not know, over lowercase c, and that one we know, which is opposite from C. Lowercase c is opposite from C, which is a 5. So when I substitute in everything I know into the law of sines, I do not have enough information to solve this. I'm going to need both of these values in one of the ratios, and I do not. So this is when we're going to use law of cosines. So when is that going to be? Well, in this example, that's when we have side angle side. So that's when we need to use law of cosines, when we have side angle side. Okay, we would have a similar situation if we were given side, side, side. Think about that. If we go back to our equation and we happen to know all of the side lengths, what if I knew this side and this side and this side? Would not be able to use law of sines for this. So we're also going to use law of cosines when we have side, side, side. So I hope that makes it clear. It's not like, oh no, I'm going to use law of sines and it's going to give me the wrong answer. If you try to use law of sines when you need to use law of cosines, it's just not going to work. So once you use law of cosines to find that first missing thing, then you can use the law of sines to finish up the problem. Law of sines is pretty easy. Now, the last thing I want to talk about is a special case. So let's look at the case when we have a triangle that has a 90-degree angle. What if we knew that measure of angle C is 90, and let's say we were also given the length A and the length B. Lowercase a is opposite from capital A, lowercase b is opposite from capital B. So we have a right triangle and we know these two sides. How are we going to find this missing side? Well, see, now it just reduces down to a good old Pythagorean Theorem problem. It's a right triangle. We know the two legs. We can find the hypotenuse by using the Pythagorean Theorem. You know, I like to say Pythagorize. I hope this little review has been helpful. Hope you'll be able to finish up your assignments, and if you need any help, just let me know. Hey, it has been a great day to learn some pre-calc.